Bronwyn is the Pingelly MLP Site Manager. She works out of the Murdoch University in WA as a research fellow and has an extensive background in on-farm genetic extension and sheep breeding research. So thanks, Bron. We've got you all up there ready to go. It's all yours.
Thanks, Fiona. Oh, 2 seconds. Thanks, Fiona. My job this morning, thanks for having me this morning, or this afternoon, sorry, we're in New South Wales. My job is to help you understand the different types of results that are provided in the MLP report. And that report is available for downloading on the website. In this case, we're looking at results for both the 2016 and 2017 drop that are included in that report. Just remember as we go through this and we look at these results that the sires are chosen to be as diverse as possible, and we're comparing different types of merinos against each other for a range of different traits. So individual sires do not represent the average of their stud, they're just the results from progeny of individual rams. In your booklet that you can download, there's a number of sections. There's a really good section on understanding the results that you can use as a reference. There's information about the sires and the contact details from the studs that they've come from. But what we're going to talk about are the results section. And there's 3 different areas here that we'll talk about. We'll talk about the raw data, the adjusted sire means, and the within site and within drop flock breeding values. Just a little tip, on the top of each of those pages, you'll see a coloured bar, green, blue, or at some sites there's a yellow, depending on the year of drop of those ewes. So anything that's green is from the 2016 drop, blues from the 2017 drop, and some sites have a 2018 drop, which is yellow. That just helps you navigate the booklet a little bit. So as I said, there's 3 different types of results that are published. The raw data, the sire means, and the flock breeding values. It's important that we understand the difference between these types of results and think about how you're going to use the data. I like to think of it as a bit of a bullseye, okay? So when we're looking at selecting a ram for breeding, what we really want to know is what's the breeding value of that ram? That is, how will the progeny of that ram perform on average? Remember, a ram only passes his genes onto his progeny, not the environment that he was raised in. So what we want is the absolute best estimate that we can get of the genes that the ram will pass on. And that's really in the centre of this bullseye. That's the true breeding value of the ram. So the question is, how do we get as close as we can to the centre of that bullseye? Well, we start with the raw data. Raw data is what we record or what we measure on the animal. And in this trait, in this project, that includes traits such as weight and growth, there's disease and carcass traits, reproduction traits, and visual scores. Okay, that's all the raw data that's either measured or recorded. And we measure this on all of the progeny from each of those sires. And what we do is we report the average value for each of the sire. Now, this data tells us how the progeny performed relative to each other over time. And what we can do over the course of this project is we can look at the cumulative performance of the progeny over their lifetime. This is the outside of the bullseye. We're close to the true breeding value, but we can get closer by accounting for some of the noise that's in that raw data. Here's just an example that we'll use as we go along. This is the yearling clean fleece weight for the 2017 drop ewes. And what you can see is I've just ranked them from 1 to 13 along the bottom. I haven't put their sire names there. You can look those up. But I've ranked them from the one with the highest yearling clean fleece weight down to the lowest yearling clean fleece weight. The average yearling clean fleece weight was 2.5 kilograms, which is this line along here. So if we're looking at selecting our top 4 rams for breeding using the raw data, we might select these 4 rams here that are ranked 1 to 4. Okay, so that's the raw data. What we've got is we've got 4 rams with progeny above the average. We've got 2 sitting right on average, and then 7 of them here sitting a bit below average. So the next set of data that we get are the adjusted sire means. So this is the average performance of the progeny of the sire again, like before, but we adjust it for some of the noise that has an effect on the raw data. And this noise isn't due to the genes, the sire's genes. So this noise includes things like an individual's birth and rear type, whether they're born a single or raised a twin, the age of the dam. Older mums are better at being mums compared to maidens. The sex of the animals, the management group, the previous reproductive performance of the animals, and these adjustments actually help us improve the accuracy. So you can see here we're getting closer to that bullseye. And the adjustments, the size of those adjustments are actually based on the actual influence of those factors on the drop. So you can see, as I said, we're closer to the true breeding value of the ram. But let's look at the magnitude of one of these effects, just so that you can see why we make these adjustments. In this case, let's look at birth and rear type. So once again, this is the yearling clean fleece weight from the 2017 drop. We've got the average yearling clean fleece weight here on the vertical axis. Along the bottom, we've got birth type and rear type. So a 1 and a 1 means born a single and raised a single. If we come over here, the 2 and a 2 means born a twin and raised a twin. Okay, so if we see the average for the animals born and raised singles was 2.6 kilograms. If we look at the animals born and raised twins, it was 2.3 kilograms. So what we can see is the singles have 300 grams more clean fleece weight than an animal born and raised a twin. Okay, similarly, born and raised a triplet down here, there's 500 grams different, half a kilo different between animals that just happen to be born and raised singles and those that happen to be born and raised triplets. Now this is significant, but it's simply due to bit of good or bad luck as to whether they're born or raised a single or multiple. Remember, these animals have come from an AI program. And so a sheep born a twin could have superior genes for clean fleece weight, but we can't see this because they just happen to be born a twin. So some of these sires in the MLP, with the MLPUs, just happen to have more multiples than others, and we really shouldn't be discounting their genetics by not accounting for this. So if we have a look here now, that's that same graph I showed you before. We've got the raw data in the darker colours here, but I've added in the sire means where we've adjusted for some of those factors. Now there wasn't big changes in this particular data set, but what we can see is if we were selecting our top 4 rams, these two here are above average for both raw data and sire means, but if we have a look here, they've dropped back. So maybe they had a lot of singles in their group and they were adjusted back. So you can see now we've got 2 above average from the average 2.5 kilos. These 4 are sitting right on average, and we've got these ones here that are sitting below average. So it's just the main difference is with those that were ranked 3 and 4. So the final results that are shown in the booklet are flock breeding values. Okay, you can see we're getting really close to that true breeding value, but we're not there, quite there. And these are calculated from data recorded within the site and within the drop. And they express the genetic potential performance of a sire relative to another sire in the evaluation. But what they do differently to our sire means is that when we calculate flock breeding values, we include information about the heritability, how heritable the trait is, the correlations between the traits, and the numbers of progeny that each of the sire has. And so they continue to improve the accuracy of the sire results by accounting for those things. Let's have a look at the impact back here on our clean fleece weight. So that was the same graph I showed you before. Before we look at the flock breeding values, let's just transfer this data so that it is actually as deviations from this average, okay? Because flock breeding values are expressed as deviations. So let's just change this raw data and the sire means to how far above the average the sires perform, progeny perform, or how far below the average they perform. And I can just do that, just like that. Okay, so this is the same information, but what we're seeing is these are deviations from the average. Okay, so you'll notice that there's a few gaps for sires 3 to 6. That's because their raw data in this case for 5 and 6 was right on average, and the sire means for those 4 animals was right on average as well. So they're just sitting on average. And you'll see once again that there's some animals with values above average and others with information below average. Flock breeding values look a bit like this as well. Okay, they're expressed as deviations. So let's have a look here. These are the flock breeding values for the same 13 rams, still ranked from 1 to 13 based on their raw data. The average is still 2.5 kilograms. The scales changed a little bit on the side here because with our breeding values for fleece weight, it's expressed as a percentage. The things we really want to take notice of here are that there has been a bit of re-ranking. If we were selecting our top 4 rams, remember they would have been like these 4 here. But what we see is there's a sire down here who was originally ranked at number 8 on the raw data, who actually is our 4th highest, has the 4th highest flock breeding value for clean fleece weight. And if we were just selecting based on the raw data, we would have missed this animal here. Similarly, number 3 isn't as good as we first thought using the raw data. Number 4 was better than we thought just using the sire means. So you can see that there can be little changes in the ranking of those animals based on the information we're using, but that information has got more and more accurate. So this is getting as close as we can to, or getting closer, sorry, to the true breeding values of the animals. And what we can see, if we were to select our top 4 animals, possibly we would have selected 1, 2, 4, and 8 based on the best information that we have. So what does this look like in terms of the data that is in the booklet? This is what the raw data would look like it looks like in the booklet for greasy fleece weight and clean fleece weight. I just want to point out a few bits of information for you. First of all, there's the age stages across the top that were mentioned earlier, yearling, adult 2 and adult 3. There's the averages down the bottom for the greasy fleece weight at each of those ages. What we can see is anything highlighted in blue is a trait leader, and you'll see this ram here, for example, is a trait leader for clean fleece weight at each of those age stages. You can see that's the same with the number of rams here. This one here is a trait leader in the raw data just at the later age stage. And you can see how many months wool growth there is on that page as well. So that's our raw data, and that's the wool data that's available. As I said, we've got information about visual scores as well. So this is the raw data. Similarly, we've got averages there on scales of mostly 1 to 5. You've got the age stages for each of the different traits, and you've got the trait leaders highlighted there as well. So there's the trait names and age stages. And this data has been collected using the visual sheep score booklet that's available on the AWI website. So we actually collect, I don't know if you know that the MLP project collects more visual traits than measured traits. So these are really important bits of data that's included in our booklet as well. If we have a look at the adjusted sire means, remember once again, we've got the age stages at the top, just the same as our raw data. We've got the averages down the bottom, and we've highlighted our trait leaders with blue here. What you can see is this, remember this ram here I mentioned earlier was a trait leader at the later stage. When we account for the number of singles and twins and the age of the dams, for example, he actually becomes a trait leader at the earlier stages as well. So that's our adjusted sire means. Remember, they've been adjusted for some of that noise that's not genetic in nature. So we're getting closer in that bullseye. These are our sire means for the visual grades. Okay, so all of the ewes are classed as either a top, flock or cull based on the visual assessment of all their traits, and that's relative to the site's breeding objective. And what we can see is the same sorts of information. We've got average values down the bottom, the age stages there, and this ram, for example, his progeny were lower than everyone else at all age stages, so had less culls than everyone else. Some of these other rams have higher tops than some of the other ones, and they're highlighted in the booklet as well. So that's the adjusted sire means. The last of those 3 bits of information are the within site and within drop flock breeding values. Remember, we don't see an average down the bottom here because the average is 0 and they're deviations above or below the mean. So we can see here, once again, we've highlighted the trait leaders. These animals produce progeny that are higher than average for greasy fleece weight and clean fleece weight at yearling and adult stage. And in most cases, we're looking at in our flock breeding values for positive values because we want more clean or greasy fleece weight. But there are some traits like fibre diameter over here that you can see where the trait leaders are the most negative values. And that's because if you were looking at improving your fibre diameter, you'd be looking at reducing it. So you'd be looking for a negative, the most negative value for fibre diameter. So make sure when you look at the flock breeding values, you look at the direction that you're wanting to either increase or decrease. So they're the three types of data that are included in the information in the booklet. There's just one other thing that I want to mention, and I guess that's what about reproduction. And this project, reproduction, is really important part of this project. Let's just have a bit of a think about the trait that's usually used for reproduction, which is number of lambs weaned. Okay, so we can have two ewes who both wean 2 lambs. But I guess the question is, how did they get there? This ewe actually had 3 lambs, but only weaned 2. This ewe had 2 lambs and weaned 2 lambs. What we don't know in this picture is how many lambs were conceived. Did they lose any before they lambed? But the end picture, if we just looked at number of lambs weaned, is they'd have exactly the same value. Okay, and that's not quite right. So what we need to think about is number of lambs weaned actually can be broken up. It's a compound trait. It's made up of a number of different events, and we need to think about what those events are. And some of those that lead to our number of lambs born include ovulation rate, conception rates, embryo survival, and lambing. And then finally, all of that adds up to our weaning percent, or our number of lambs weaned. So how is this, what are we doing with this information, and how is MLP contributing to this information? We're using data from preg scanning and from our marking and from our weaning. And what's happening is the MLP data is contributing to the national analysis that's being carried out for reproduction by sheep genetics. And what has been put forward is that actually number of lambs weaned is made up of 3 component traits that include conception, that includes litter size, and includes ewe rearing ability. Okay, and number of lambs weaned is calculated based on a combination of those 3 traits. So it allows us to split it into its component traits. You'll see some sires are just particularly good for number of lambs weaned because they were good all the way across for conception, litter size, and ewe rearing ability. But other ones, for example, may have just had particularly good rearing ability or high conceptions. I'm going to leave it there. All of this information is available in the site booklet for you to have a look at. But I hope that's helped you understand, particularly some of those the differences between the raw data and the sire means and the flock breeding values.